Flight through space is much more difficult than flight through air. Air can push against a plane, and a plane can push against the air, making it easier to change its orientation. This is not the case in space, where there is no air to push against. Instead, a spacecraft must rely on a series of thrusters to carefully change its orientation in 3 dimensions. These thrusters work in accordance with Isaac Newton's third law of motion. This states that for every action, there is an equal and opposite reaction. When a thruster releases gas, a force equal to that of the gas pushes against the spacecraft in the opposite direction. The tricky part of spaceflight is related to Newton's first law of motion. This states that objects will continue traveling in the same direction and with the same speed unless acted on by another force. Therefore, when a thruster is fired to change a spacecraft's orientation, the spacecraft will continue moving in that direction. To keep the spacecraft still, other thrusters must be fired in just the right amount to balance the force of the initial thrust. The 3 directions a spacecraft can turn are called roll, pitch, and yaw. Roll is the spacecraft's side-to-side rotation around its horizontal axis. Pitch is the spacecraft's up and down rotation around its horizontal axis. And yaw is the spacecraft's rotation around its vertical axis. Controlling a spacecraft's roll, pitch, and yaw with exquisite precision is necessary for 2 spacecrafts to dock together.